Okay, so we're starting chapter 2, and our first section is to look at a different way of measuring angles. This is referred to as radian measures of angles. We'll describe the angles in terms of circular motion around the circumference of the circle. So we're going to talk about how we can use radian measure and how we convert between degree and radian angle measures. Okay, so we have discussed angles in the past or so far. We know that we have an angle where the initial side is along the positive x-axis, and we locate the terminal side based on the rotation of being positive or negative. Remember that a common unit of measuring angles is the degree. There are 360 degrees in one complete revolution around the circle. Angles can be measured more precisely by expressing 1 degree as 60 minutes and 1 minute as 60 seconds. As an example, an angle of 46 degrees, 30 minutes, and 9 seconds is written using the symbols 46 degrees, 30 minutes with the apostrophe, 9 seconds with the quotes. Okay, so another unit of angle measurement is the radian. When an arc of a circle has the same length as the radius of the circle, the measure of the central angle is referred to as 1 radian. So what we're looking at is an angle. Central angle is when the vertex is at the center of the circle. So this is a central angle. You would have learned this in geometry. So if the radius of this circle is equal to the arc length, and arc length is part of the circumference going around the circle. Let me get the laser pointer. So think of a piece of string that you would take and wrap around the circumference of the circle and then straighten it out, and the length of that arc would be equal to the radius. So then in terms of the arc length, we say that the central angle has a measure of 1 radian when the radius equals the arc length. Okay, so as an example, depending on what the unit of measure is, it may look differently. So it's because we know we have different units of measure. We have centimeters, decimeters, meters, millimeters, we have inches, half inches, etc. So if the radius is 1 unit and it cuts off an arc of the same length or unit, then that's referred to as 1 radian. Okay, so the radian measure is derived by wrapping a number line around the unit circle, which remember is a circle with a radius of 1. So think about this number line, that we have a circle, and the center of the circle would be at the origin. So we have our x and y axis. Think of this number line being tangent to the circle, meaning it touches the circle once, and it's tangent at the point where the circle intersects or passes through the positive x-axis. And this point would be 0 on the number line. And the units on the number line are equal to the radius of the circle. So one radius, 1 is equal to 1, or the radius is 1 unit, and the units on the number line are the same. Think of this number line as being a piece of string, and we start wrapping it around the circumference of the circle. So 1 would map to this point on the circle. 2 units would map to this point on the circle. 3 units maps to this point on the circle. So each of these would be called radians. This is 1 radian because the arc length equals the radius. This would be 2 radians. This would be 3 radians. And as we continue wrapping around the circle, thinking still of this a piece of string, then when we get to 4, it would map to this point. 5 maps to this point. And then 6 would continue on around, and you can see that 6 would be about right here. So this would be 1, 2, 3, 4, 5, 6 radians. So if we draw rays from the center of the circle to the points 1, 2, 3 on the circle and respectively all the way around, we can see those corresponding points. Okay, so what we're going to talk about is how can we relate these radians to degrees, and we know that 360 degrees wraps all the way around. So now let's talk about how that connects to radians. So we have our circle with a radius of 1 unit, and if we talk about the circumference of the circle, and if the radius is 1 unit, the circle has a radius of 1 when the r is equal to 1. So the circumference would be 2 pi r, or 2 pi times 1 with the radius of 1, which gives us 2 pi. So the circumference of a unit circle is 2 pi. 1 revolution measured in radians is 2 pi. 1 revolution measured in degrees is 360 degrees. So 2 pi radians is equivalent to a rotation of 360 degrees. All right, so let's look at how we develop these conversions. So we have 1 revolution measured in 2 pi radians. We can divide by 2 pi so that we can find the equivalent of 1 radian. So 360 divided by 2 pi, we get 1 radian equals 1 pi over 180 when we reduce 360 by 2. And then similarly, 2 pi over 360, if we divide both sides by 360, then we will have reducing 2 over 360 is pi over 180, and that's equal to 1 degree. So our conversion formulas then, we have 1 radian is pi over 180, and 1 degree would be multiplied by, this is 180 over pi, and we can multiply by pi over 180. So these are called the conversion formulas. These are the conversion factors. If we want to convert radians to degrees, we multiply by 180 over pi, because 1 radian equals 180 over pi. If I want to change from degrees to radians, I multiply by pi over 180, because 1 degree is pi over 180. So to convert 2 degrees, we multiply by 180 over pi. To multiply degrees to radians, we multiply by pi over 180. Okay, some examples. Converting to radians, we want to go from radians to from degrees to radians, I know then if I want radians, I'm going to have pi in my numerator so that the degree unit cancels out. So 45 degrees, we multiply 45 times pi over 180, and we get 45 divides into 180, so that reduces to 4, so we have pi over 4. 30, we have 30 times pi over 180, 30 goes into 180 60 times, we get pi over 6. And then 60, we'll do 60 times pi over 180 as our conversion factor, factor meaning multiply. 60 goes into 180 3 times, we reduce to pi over 3. So degrees to radians will have pi as a factor, and it'll be in the numerator. So now let's convert from radians to degrees. We're going to multiply by 180 over pi, and I know if I'm going 2 degrees, I want to divide out the pi. So we have 5 pi over 6, and we're going to multiply by the factor 180 over pi. Notice the pi unit will cancel out, and we have 6 goes into 180 30 times. 30 times 5 is 150. Then 3 pi over 2, we're going to multiply by 180 over pi. The pi units cancel out. 2 goes into 180 90 times, and 90 times 3 is 270. And then 7 pi over 3, multiply by the conversion factor of 180 over pi. The pi unit cancels out. 3 goes into 180 60 times, and then 60 times 70 is 420 degrees. So you're going to be practicing these in your homework. So this is a summary. You'll get this note sheet of how we're going to be working with our unit circle, our polar graph rather, and we'll look at how we can see the patterning and the fractional parts as we go around the circumference of the circle. So 360 is 2 pi all the way around. Halfway around would just be pi, because half of 2 pi is pi. And if we just go from 0 to 90, that's pi over 2. And then from 0 to 60, that's pi over 3. And then 45 is pi over 4, and 30 is pi over 6. So we'll be talking about these and looking at patterns. And here's some additional examples that you will have to refer to. So this will be the homework that you're going to complete. It'll be posted in my Mullen for you to download.